Hello, class, and welcome to week 7. I want to go over the lab for this week, which is build an atom, isotopes, and atomic mass. And so for this particular lab, you scroll down and you see that you have a total of 15, nope, it is wrong. You have a total of 17 questions, so I need to update the instructions on that. So you have 17 questions that you will be working on for this lab. And so I want to go over the simulations and just give you a brief overview of what you're doing for this week. All right, so for this first question, you're going to open the build an atom simulation. And like I've said before, you want to right click on it, open the link in the new tab. That way you can go back and forth between the simulation and the instructions. And so it says to click on the symbol simulation, and you want your protons, neutrons, and electrons to look like this. And so we are going to the symbol, okay, so not the atom, but the symbol, and you want to click on that. And so it shows one proton, one neutron, and one electron. And it says neutral. So that looks like what we have here. And it says now drag another proton from the basket to the atom. So if we drag another proton, we see that it changed from hydrogen to helium, and it also has a plus ion. Okay. And so that's what you're going to describe in the box. Okay. And then you're going to do similar on question number 2. All right. And then question number 3, you're going to drag protons, neutrons, electrons so you get the symbol below. Okay. So you're still working with the same, excuse me, simulation for that. Still with the symbol simulation. All right. Now we get to the build an atom simulation. All right. So we're going to go there. All right. Or you can right click on there. Okay. So this, we're still looking at the symbol simulation. Okay. So I was incorrect on that one. So we're still in the symbol simulation. So we're going to stay there and we're going to click on the symbol simulation. And then we want to build the following atom. We want to know what is the charge on the ion above. Okay. And so it's going to give you that. Still in the same thing, but we're going to look at this particular element with the negative charge. The top number is your mass number. The bottom number is your atomic number. And so remember the atomic number here, the number 9, that represents the number of protons, okay? If there is a charge here, then you would, if it's negative, you're going to add that number to the number of protons. That'll give you the number of electrons. If it's positive, you want to subtract from the protons. That'll give you the number of electrons. And if it is neutral or 0, then the protons and electrons are the same. Okay. And the reason why, if it's negative, you're adding, that is because remember, electrons are negative. And so that's telling you have one extra electron. So you would have 10 electrons instead of 9. If we take 19 minus 9, sorry, my voice is a little hoarse. If you take 19 minus 9, that gives you the number of neutrons, which is 10. So 19 minus 9 is 10. That's 10 neutrons. Okay, so that's how you use these symbols to determine protons, electrons, and neutrons. All right. So this time we're going to click on the symbol simulation again. And then given this, determine protons, electrons, and neutrons. All right. And so then based on our observations for question 1 through 8, we want to write 5 to 10 sentences concluding a summary of what you have learned. Okay. All right. So now for this one, number 10, we're looking at isotopes and atomic mass. So we want to click on this link and we want to choose our isotopes. Okay. So it's going to open up. We want to choose isotopes. All right. So notice that when you click on the symbol and abundance in nature options to show the additional information. Okay. So here, all right. So if we go here, we see abundance of nature and symbols. So we have different options that are available to us. Okay. All right. So how now add another neutron to the carbon atom. Which of the following is the correct symbol? Okay. And so when you're looking at this, we want to click on carbon. Okay. So this will tell us which elements we're clicking on, okay? And then you can add neutrons. When we're talking about isotopes, the two things that change with isotopes is the number of neutrons and the mass number, okay? So those are the two things that are going to change. The number of protons and the number of electrons remains the same. And so you're going to go through and answer the questions based on isotopes, okay, for these next few problems. And then we get down to this one. I think this is okay, that's the isotopes. So this one starts with our mixtures, okay? And so we're going to go to this simulation. We're going to click on this. Instead of isotopes, we're now working with mixtures, okay? And so we're going to click on our mixtures. All right, and so we want to click on the symbol chlorine on the periodic table, then add 9 chlorine 35 atoms and 1 chlorine 37. So if we click on third chlorine, okay, then we have our chlorine down here. And so we would do 9 chlorine 35 and 1 chlorine 37. So we have, all right, we got 9 and 1 chlorine. Okay, 37. All right. And so it should look like this or similar. Okay, like that. And now you want to answer the question, what should the average atomic mass of each atom be equal to? Show your work in the calculation. Okay. And so this is your average mass. But when we're looking at how to do the calculation, right? So chlorine 35 has a mass of 34.96885. Chlorine 37 has a mass of 36.96590. And we're looking at the average mass. And so we have um, 9 of our chlorine 35, 1 of our chlorine 37. So we have about 90% chlorine 35, 10% chlorine 37. Okay, if we're thinking about out of 100, all right, 90% is 35 and 10% is 37. So to do the calculation, you're going to take the mass of chlorine 35 and we have 90% of that mass. And so you're going to change that 90% to a decimal. So that would be 0.90. So I'm just going to write this in the box so you get the hang of it. 34.96885. And you're going to multiply that by 0.90. Okay. And then you're going to add to that 36.96590. And you're going to multiply that by 10% change to the decimal, which is 0.10. And you're going to see what that's equal to. And that will give you your average mass. Make sure that you do show your work for this calculation so that you get the credit for that. Okay. All right. And so then you're going to answer the question here. Okay. Same concept that we did for the previous problem. Now you're going to look at silicone. Okay. And look at that particular example as well. Which five elements in the simulation have only one naturally occurring isotope? Okay. And so you're going to look at each of these and see which one only has one. So if we look at hydrogen, it has two, so that's not true. And we already looked at chlorine, so we know it's not chlorine. We know it's not carbon. Okay, so you're going to click through to see which five elements only have one isotope. Okay. And then number 16, you'll answer the question for there. 17 is where you do your summary of what you learned from questions 10 through 16. Right. And if you have any questions as you're going through this lab, please let me know. Thank you and have a great day.